Okay, Bailey and Savannah. Here are your problems. We did 31 through 35, 43 through 45. There's 31. The final answer is in purple. 33. Final answer is in purple. Got really skinny because it's 3 times skinnier. 35. Final answer is in purple. 43. Final answer is in purple. 45. Final answer is in purple. Today, we are going to do tangent and cotangent. So, view, rule lines, draw. Tangent and cotangent. So, in the olden days of me teaching this, what I did is I had them draw graphs of the original function and then change it and then change it again. And then we had lines going everywhere. And it was so confusing that when we're graphing tangent and cotangent, all I want is the final graph. Okay? So we're going to figure out where the points are and then manipulate them from there. So we're going to look at the tangent graph and the cotangent graph and just graph those. And then we'll do the plus and minus and 3 times skinnier and this and that and the other thing. And then I'll show you what I want in the end. All right. So to graph y equals tangent of x. All right. What's the tangent of 0? Ooh, unit circle time. What is the tangent of 0? Y over x. 0 over 1 is 0. What's the tangent of pi over 4? 1. What's the tangent of pi over 2? 1 over 0 is 1 divided by 0. Undefined. 3 pi over 4. -1. Pi. 0. 5 pi over 4. 1. 3 pi over 2. Undefined. 7 pi over 4. -1, 2 pi. Back to 0 again. Okay? I'm just going to make my graph a different color just so it's easier to tell colors apart here because I'm going to make my asymptotes a different color. All right. So pi over 2, pi, 3 pi over 2, 2 pi, 1, 2, -1, -2. All right, so I'm going to put my purple dots down. 0, 0. Pi over 4 is halfway in between 0 and pi over 2. So pi over 4, 1. Okay. Then pi over 2 is undefined. So that's going to be an asymptote. And then 3 pi over 4 is halfway in between pi over 2 and pi. That's -1. Then we have 0. Then we have 1. Then we have another one of those cotton picking asymptotes. Then we have -1, 1, 1. And then we have an asymptote. That's probably enough. Okay. What happens as a line gets close to an asymptote? Does it cross it? Can a line ever cross a vertical asymptote? So if it's going up, do you think it'll all of a sudden go down again? No, it just keeps going up alongside of it. As it goes down alongside of it. So the tangent curve looks like this. Not a parabola, but more of a x cubed type curve. Okay, that's a tangent curve. Now, wherever you're going along a tangent curve, is it positive or is the slope positive or negative? Positive. You're always having a positive slope. It's always going up, tangent curve. Okay? All right. Change color here. I'll go green. So now let's look at the y equals cotangent of x curve. What's the cotangent at 0? So what is x over y at 0? Undefined. Pi over 4. 1. Pi over 2. Pi over 2. We have 0 divided by 1, which is 0. 3 pi over 4. Negative 1. Pi is undefined. 5 pi over 4. 1. 3 pi over 2. 0. 7 pi over 4. And then undefined at 2 pi. All right, I'm going to draw in my asymptotes right away. My asymptote is at 0. And pi. And then 2 pi. Okay, so at pi over 4, I'm at 1. Pi, I'm at 0. 3 pi over 4, I'm at negative 1. 5 pi over 4, 1. 3 pi over 2, 0. 7 pi over 4, negative 1. So I'm kind of got an asymptote going. Slide this way, asymptote going. And there you are. So what's the slope, no matter where you are on a cotangent curve, going to be? Negative. So tangent goes up from left to right. Cotangent goes down from left to right. It just makes a difference where the asymptotes are. Okay? All right. Let me pause this for just a second. I gotta look at one thing really quick. Boom, boom. All right. So let's graph y equals -2 tangent of x minus pi over 2. All right, gets a little complicated now. Okay, what I tell people to do is, all right, you have your XY chart for the normal tangent. So you go y equals tangent of x, which is 0 for tangent 0, 0. Yeah. 0, 0. Pi over 4, 1. Pi over 2, undefined. 3 pi over 4, -1. Pi, 0. 5 pi over 4, -1. Or +1. Thank you. And then 3 pi over 2, undefined. 7 pi over 4, -1. And then 2 pi, 0. And then you have your y equals -2 tangent of x minus pi over 2. Woo. Now, what does x minus pi over 2 do to the graph? Moves everything to the right, pi over 2. So this point that was at 0 is now at pi over 2. So that's where we're going to start. And then what does the -2 do to it? Multiplies the y value by what? -2. What's 0 times -2? 0. So I'm going to start at pi over 2, 0, because I moved everything to the right, pi over 2. Well, what's pi over 4 plus pi over 2? Well, it's 3 pi over 4. Multiply 1 times -2, you get -2. Pi over 2 plus pi over 2 is pi. Undefined times -2 is still undefined. Undefined times anything is undefined. Then 3 pi over 4 plus pi over 2 is 5 pi over 4. And then -1 times -2 is a +2. Pi is 3 pi over 2. 0 times anything is 0. And then it's 7 pi over 4, -2. 2 pi, undefined. 9 pi over 4, 2. And 5 pi over 2, 0. So you're not going to graph your original curve because it just gets too many lines in there and too much going on. So I got pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 1, 2, 3, negative 1, negative 2, negative 3. All right, so pi over 2, I'm going to have a 0. Three pi over 4 is negative 2. I'm going to have an asymptote at pi. 5 pi over 4, 2. Then 0. Then negative 2. Then an asymptote. Then 2. Then 0. So what's happening back here? Well, if I go back, I bet it's at 2, following the pattern, and then we'd have an asymptote here. So it's just a taller, skinnier curve. It's actually basically the cosine curve times 2 is actually what it happens to be. Okay. So if you can get how do we get points from there to there? It's easy peasy lemon squeezy. No problems whatsoever. Okay. This affects the y, this affects the x. All right, so now let's do y equals the cotangent of 2x plus 1. So we got to first write down y equals the cotangent of x terms, where they're at, so then we can go off of that. At 0, the cotangent is undefined. At pi over 4, it's 1. Pi over 2, it's 0. 3 pi over 4, it's negative 1. 2 pi, 0. 5 pi over 4, 1. 3 pi over 2, 2 pi is not 0. 2 pi is, whoa, why did I say 2 pi? Mr. Beerschbach, come on. It's undefined. Okay, 1, 0, negative 1, undefined. Okay, that's a normal cotangent curve. So y equals cotangent of 2x plus 1. Okay, what does the 2 affect in this? The x or the y? The x. Because it deals with period, the 2 is making it shrink down. So whatever happens on the inside of the parentheses affects the x. Whatever happens on the outside of the parentheses affects the y. So then what does this plus 1 do? Up 1. Okay? So 0 is still 0 because 2 times 0 is 0. So it doesn't affect the x on the first one. And undefined, moved up by 1, is still undefined. Now instead of going pi over 4, I'm going basically the 2 squeezes it down, so it's halfway there. So then it's pi over 8. And then I go up by 1, which gives me 2. 1 plus 1 is 2. Then what's half of pi over 2? Pi over 4. And that's going to give me up by 1. 0 plus 1 is 1. And then half of 3 pi over 4 is 3 pi over 8. 0. And then pi over 2, because half of pi is pi over 2. And back to undefined again. Okay, then 5 pi over 8, up by 1. 1 plus 1 is 2. And then 3 pi over 4, 1. 7 pi over 8, 0. Pi, undefined. So pi over 2, pi, 3 pi over 2, 2 pi, 1, 2, 3, -1, -2. All right, so we're going to graph the purple one. My asymptotes are going to be at 0, pi over 2, pi, and be at 3 pi over 2 and 2 pi, but I'm not going to graph all those. And so at pi over 8, if it's 8 to get to pi, pi over 8 is just 1 square. So 1 square, I'm up at 2, then 1, and then 0. 2, 1, 0. So it's really skinny like this, or like that. So if I would graph the original cotangent curve, then I would have asymptotes in different spots, and then curves crossing curves and all that. And that's how it gets so confusing. So that's why we use this to help us out. Okay? Are we good there? Do you want to see more? No? All right. This is all we're doing today. So you're going to have 45 minutes or so to work on this. I'm only going to give you 4 problems, so it's not going to be too bad. Might not be, now there's only 4 problems. I'm going to say it might not be a bad idea